Okay guys, here we go. So we just reviewed how to graph. Now we are going to actually use graphing to solve equations. So you are given a function y equals negative 2x plus 5, and you're asked to complete the table and to graph it. So before we get started, I would like to say that this is going to be a very important example for you to have when you're working on 16.1 homework. So I'm going to star that. You might want to be coming back to this question when you're working on that homework. Just a suggestion or recommendation. Okay, so normally if we were at school and we had our graphing calculators, we would put the equation in y equals, pull up a table, no big deal. Well, we're not in that situation right now, so we're going to use the resources that we do have. What I like is Desmos. I know that some of you like to use the calculators on your cell phones. I would strongly encourage you to pull up Desmos and use that instead, because it can get a little tricky when you're trying to punch in negative numbers and you don't really have parentheses, so it can cause you to get the wrong answer. So Desmos, I'm pretty sure all of you have this on your phone already or saved on your laptop from when we were in school, but just in case, that's it, Desmos. There's an app for Android and for Apple, so that might be something you want to get to. All right, so here's what we're going to do. We are going to use this function and we're going to fill out the table by plugging these x values in. So if I want to know what y is when x is negative 2, what I'm going to do is I'm going to plug negative 2 in. So I have negative 2 times the negative 2 I'm substituting plus 5. And when I calculate that, that's going to give me 9. Okay, you can do it in your head or you can type it in Desmos just as you see it and it'll calculate it for you. And that's basically how I'm going to fill out this whole table. I'm just going to continue the process. Negative 2 times negative 1 plus 5 gives me 7. Negative 2 times 0 plus 5 gives me 5. Negative 2 times 1 plus 5 gives me 3. Negative 2 times 2 plus 5 gives me 1. Negative 2 times 3 plus 5 gives me negative 1. And negative 2 times 4 plus 5 gives me negative 3. Okay. So you could do a couple different things here when you're being asked to graph. You could use your slope and y-intercept from the equation, or you could plot the points that are given to you in the table. Probably easier just to plot the points from the table, so that's what I'm going to do. I'm going to plot the point negative 2, 9, so left 2, up 9, negative 1, 7. This is also going to give me a much more accurate line. So x is 0, y is 5, 1, 3, over 2, up 1, over 3, down 1, and over 4, down 3. Okay, so there's my line. I'm not going to connect it because I think I would mess it up if I tried to connect it. So that's what our line looks like, and I could even extend that further if I wanted to. You can kind of see how we're just following that pattern of down 2 over 1. And that comes from the slope being negative 2. So as we move on, we are looking at question number 2 now, and we are looking at how we can use our responses from question 1 to solve these equations. So we are looking at letter A, and I'm going to try to color code here so that it's a little easier to follow. So if I'm looking for where negative 2x plus 5 equals 9, I can do one of two things. I can look at the graph and find where y is equal to 9, or I can look in the table and find where y is equal to 9. So I'm gonna show you both. So if I look in the table, I'm going through my y column and I'm looking for where y is 9. And I happen to find it right here in the first entry. So when we report solutions, we want to report the x value. So where does the intersection occur? Where is negative 2x plus 5 equal to 9? Well, it's equal to 9 when x is negative 2. Okay. We can also use the graph for that. So we can also find where y is equal to 9. So I'm just kind of dashing in a little horizontal line where y is 9. And I can follow that down to my x-axis. And that happens where x is equal to 2. Okay, so you could use the graph, you could use the table. Either one works. Letter B. We are looking for where negative 2x plus 5 is equal to negative 7. I'm looking at my table and I don't really see in my table where y is equal to negative 7. So for this one, because I don't have negative 7 in my y column, I can't use my table. So my only other option is to take a look at my graph. So that's what I'm going to do. So I'm going to find where y is equal to negative 7. And I'm just going to kind of sketch in my horizontal line here, like I did before. So that's where y equals negative 7. And you can see the point is there. And I'm just going to trace that back up to the x-axis to find out where that's actually happening. Okay, so that's actually happening at x equals 1, 2, 3, 4, 5, 6. So that is happening when x is equal to 6. Letter C. 4 is equal to negative 2x plus 5. Again, I don't see 4 on my table anywhere. However, if I look at my table, I can kind of say, okay, well, I see 5, I see 3, and I know 4 is directly between 5 and 3. It's exactly halfway. So I can kind of look at my table and figure out what the solution would be. Since 4 is halfway between 5 and 3, my solution has to be halfway between 0 and 1. So my solution has to be x equals 1/2, or x equals 0.5. And we can look at the graph as well and check out how that happens. So if I take a look at my graph at where y is equal to 4, which is right here. I'm going to draw in that line, y equals 4. Okay, I can trace this back down and see that that intersection occurs where x is between 0 and 1, which would be your 0.5. All right, what color do I want to use now? Let's use this one. Okay, so for D, we now have not only negative 2x plus 5, but we also have another equation. Okay, so we are gonna have to look at where these two intersect each other. We're gonna have to graph them because we don't have a table that shows negative 3x plus 8. So if I want to graph negative 3x plus 8, I'm going to start with my y-intercept, which is 8. And I am going to follow my slope, which is -3. So I'm going to go down 3 and right 1. So down 1, 2, 3, right 1. Down 1, 2, 3, right 1. Down 1, 2, 3, right 1. And you can see that I have just overlapped my pink line right there at that point. So where does that actually happen? When x is 1, 2, 3. So the intersection is 3, -1. We would say that the solution is x equals 3.